Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of simplifying square roots. This is standard A.11A in the great state of Texas, and we are using item number 1 of the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we have this expression here, 7 times the square root of 45, and we need to find an equivalent expression. Now, we can and we will check our answers with the calculator. If we wanted to, we can just plug all of these expressions in the calculator, find the two that match, but we can also do it without a calculator. And let me show you how. We already have this 7 sitting outside of the square root, so there's not really anything we can do with that. But what we need to think about is we need to think about that square root of 45. Now, square root of 45 in itself is going to be an irrational number, so it's not going to be a perfect square, but let's think about perfect squares, right? So the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, and let's just go ahead and get all the way up to 45, and we'll stop. Square root of 25 is 5, square root of 36 is 6. Square root of 7 is, square root of 49 is 7, so too big. All right, so what we're looking for is we're looking at that 45. How can we split up this 45 into two factors, with one of the factors being one of these square roots here? Because if we can make one of these square roots one of the factors of the square root of 45, then we can get these perfect squares. And hopefully you're thinking, you know what? There's many ways to make 45, but one of the ways to make 45, right, is going to be 9 times 5. So, and the same way that 45 is 9 times 5, we can say the square root of 45 equals the square root of 9 times the square root of 5. So what we're doing is we're just breaking apart that 45 into 9 times 5. Since they're both under the square root, we're going to make it a square root of 9 times the square root of 5. Now, why does that help us? And let's go ahead and keep this 7 there so we don't lose it. So we've got 7 on the outside, right? Well, this helps us because we can think of that 9 right there as the square root of 9. We can say, well, that's actually 3. Okay, so the square root of 9 is going to be 3. So what I'm gonna do is I'm gonna pull that out here, and I'm gonna say we've got 3, and then times the square root of 5. And we still got that 7 hanging out there. Doesn't matter whether it's front or back. So I took that 45, split it into a square root of 9 and square root of 5. The square root of 9 is actually 3, so I pulled it out. Now I've got two numbers on the outside. They're both multiplying by the square root of 5, which means I end up needing, if you pull it up here, it's not going to be 73, it's going to be 7 times 3. So it's going to end up being 7 times 3 is 21, times the square root of 5 is the same as 7 square root of 45. Because you took that 9, right? You took that 7, I'll write it again like this. Took that 45, split it in half, and you just took that 9 out. Square root of 9 is 3, multiplied that by 7. But don't trust me. Let's verify with a calculator here. All right, so what we're going to do is we're going to open up this calculator, and we're just going to plug these numbers in. So first, let's just do the actual number, right? The 7 and times let's get that second, square root of 45. What do we have? All right, so we'll just make that 46.957 is that, and let's check what we think our answer is, right? 21, and then we need that second to hit that square root, and then 5, and look at that, exact same thing. All right, so if you wanted to, right, you could plug each of these three in, A, B, and C, verify that they also don't work. Our answer here is D, 21 square root of 5.